Hello friends, good evening, good morning and good afternoon. Today we start learning about core concept of Kafka and let's get started. So today's agenda is that what is Kafka and some features of Kafka. What is the traditional method for using message transferring and what is the major components of Kafka and core API we used in Kafka, as we know that it's a basic concept of Kafka, and how to Zookeeper used in Kafka and how to start server in Kafka, how to monitor Kafka, what is the purpose of partitions, real world usage of Kafka, and what some disadvantage of Kafka. So let's start it. First we discuss like what is Kafka, and I will explain you with example. So here is like some e-commerce website. Let's take example. An online e-commerce platform like could use to Kafka for tracking user activity in real time. Each user activity such as product views, like cart addition, purchases, reviews, search queries, and so on. And it could be published as event specific Kafka topic. These events can be written to storage or consumed by real time by by various microservices for recommendation, personalized offer reporting, and fraud detections. So Apache Kafka is free and open source streaming platform. Initially created at LinkedIn as a messaging system, it's grown to be much more versatile. It handles data streams and can be used in various scenarios. Kafka is distributed, meaning it scales up by adding new server to the clusters. It processes large amount of data quickly and low latency for real-time processing. It works with multiple programming language, not just like a Scala and Java. And unlike traditional message queue like RabbitMQ, Kafka retain message for a period of time, like default 7 days after they receive the RabbitMQ immediately delete message after they confirm by the consumer. Kafka scales horizontally by adding more nodes, while RabbitMQ manages consumer load by controlling the number of messages each consumer processes. Kafka is used for fault-tolerant storage, publishing, subscribing to stream of record. It's commonly used for messaging, website activity tracking, log aggregations, commit log. However, it's not suitable for use a database as it lacks data schema and indexes. So basically that's a Kafka, and there's some kind of features in Kafka. So there are following features. So Kafka is messaging system built for higher throughput and fault tolerance. Kafka has built in the partition system known as topic. Kafka include a replication features as well. And Kafka provide a queue that can handle large amount of data and move message from sender to another. Kafka can also save the message to storage and replicate them across the cluster, and that coordinate and synchronize with other service. Kafka collaborate with like a Zookeeper, and Apache Spark is well supported by Kafka. As we know that there is a 10 features I like defined with pictures, like durability, performance, like zero downtime, extensibility, replications, high volume data maintain, scalability, reliability, fault tolerance, data transformations. So that features provided by Kafka. So what are the traditional method of message transferring and what the better for them? So messaging queue is the best, like the messaging queue is traditional method like of message transfer that following point to point pattern. It work like a post office where messages are placed to in a queue and removed once they are consumed, similar delivery delivering mail to the recipient. So this process allow for asynchronous message. In there is delay delivering message due to network issue or unavailable consumer, the message remains the queue until it can be sent. Can result in message being processed out of order as they are handled on first come first serve basis. So however this approach can improve efficiently in certain situations. Suppose like as you've seen that in pictures, like produce message and that would be stored in on the queue. After that consumers subscribe that like particular message or topic. After that that can be like receive that response. traditional message transfer. Another one is like publisher subscriber models. Like publisher subscriber model is messaging pattern where publishers send message different category and subscribers receive those message from the category they are interested in. Unlike point-to-point messaging, message is removed only after all subscribers have consumed it. Kafka simplified this model using consumer group, which combine the benefit of both, like publishers and subscriber and messaging queue. Now let's understand why Kafka is better than traditional message technique. Scalability. Kafka uses a cluster of devices to divide and distribute data, allowing it to handle large amount of data and expand storage capacity easily. So it can be faster, like single Kafka broker can efficiently handle thousands of clients managing significant amount of data reads and write per second. Durability and fault tolerance. So like Kafka ensured that persist and tolerance to hardware failure by replicating the data across the cluster, preventing the data loss. So in simple terms, Kafka's strength lies in its ability to handle large number of clients, store data safely, and distribute messages efficiently across the cluster of devices. These features make it powerful and reliable choice for messaging needs compared to traditional method. So in this picture, as you seen that, like publisher publish message, and there is a like in between there is a channel like publish subscriber channels where the message would be stored in queue, and a subscriber consume that message and like required message if the subscriber interested like that message, so it would be like consume that message from the queue. So that. So next is what are the like major components of Kafka. So there is a following major component of Kafka, as you see in that like Apache Kafka architecture. So like first one is Kafka producer. So like the producer act as like a sender. It responsible to sending a message or data. It does not send message directly to consumer. It push message of Kafka server or broker, and the message or data are stored in Kafka server or broker. Multiple procedure can send a message to same Kafka topic or different Kafka topic. As you see in that second one is like a Kafka consumer. Like that can be pull the message. Consumer act as like a receiver. It responsible to receiving and consuming the message, but it does not consume receive message directly from the Kafka producer. Like Kafka producer posts message to the Kafka server or broker. Consumer can request a message from the Kafka broker. If Kafka consumer can enough permissions, like it gets message from the Kafka broker. So like third one is like broker, like Kafka broker. So Kafka broker is nothing but just server. Like simply put a broker in like immediately entity exchanging message between producer and consumer. So like a Kafka producer act as a, like a receiver, and Kafka consumer acts like a sender. And in this Kafka cluster there is like one or more Kafka broker, as you see in that like broker 1, broker 2, broker 3. So like what is like inside that like Kafka cluster, what is that? So like Kafka cluster, now first we understand what is the cluster. Cluster is a common terminology in distributed computing system. It is nothing, just a group of computers that are working in a common purpose. Like Kafka is also a distributed system, so it has a cluster with a group of server. It's called like a broker. So there can be one or more broker in the clusters, as you see in that in picture. Like single broker cluster, like Kafka cluster having only one broker is called like a single broker cluster. Multi-broker clusters like a Kafka cluster having two or more broker is the called the like multi-broker cluster. Have you seen that in this picture? So what is the like Kafka topic inside that like that? It is one of the most important component of Kafka. Kafka topic is a unique name given to the data stream or message stream. Now let us understand the need of this. So as you know, Kafka producer send a message to stream to the broker, and Kafka consumer receive message stream that broker. Suppose consumer want to consume a message from the broker, but question from which message stream? Question is that. So there can be multiple different message stream on same broker as we seen that. So coming from the different Kafka producers. So here come the concept of topic, which is uniquely identify the message stream. Producers send a message to a unique name called the topic of the message stream. So multiple producer can be also send the same topic. If any consumer want to consume the message, it subscribe the topic in Kafka broker. So the consumer will receive all the message coming to the topic. Got it? So next one is like a Kafka partition. So what is that? Now we know that producers send the data to the broker with a unique identity called a topic, and brokers store the message with the topic. Now you have huge volume of data, and it is very challenging for broker to store data in a single machine. As we already know that Kafka is distributed system. In such scenario, like we can break the Kafka topic into the partition and distribute the partition on different machine, like to store based on the use case and data volume. Like we can decide the number of partition for a topic during a Kafka topic creations. So like in Kafka, sequence number is assigned to each message, each partition of Kafka topic. Sequence number is called like a offset. As soon as like any message arrive in partition, a number is assigned to the message for given topic. Is a different partitions have different offsets. So offsets number is always local to the topic partitions. There is not any offset that is global to topic or each partition of the topic. Initially, the offset pointer point the first message. As soon as consumer read the message, offset pointer move the next message, and so on in the like sequence. So like combining the topic name, partition number, offset number is a unique identity for any message. In other words, you can find any message based below, like there are three components: topic name, partitions, and offset. So another one is, what is a Kafka like consumer like group? So like a Kafka consumer group is a group of consumer, like multiple consumer combined to share workload, just like to divide a piece of large task among the multiple individuals. There can be multiple consumer like groups subscribing to like same or different topic. Two or more consumers, same consumer group do not receive common message. They always receive different message because the offset of pointer move the next pointer. Once message is consumed by consumer in the group is that group. So like that, what is the like Zookeeper? So Zookeeper is a that is the like distributed system. It uses Zookeeper to coordinate and track the status of Kafka cluster node. It's also keep track of Kafka topic, partitions, offset, etc. So here is the conclusion is that as we seen that Kafka is combining distributed like streaming platform. It act publish subscribe message system, but it not like normal message system. It help to industry build big data streaming pipelines, streaming applications. We have also seen that producer does not send any message directly to the consumer. Broker is centralized component. And got that? Broker is centralized component that help to exchange message between producer and consumer. So there are following major component of Kafka. Like first is topic. So a topic is a category or field in which records are saved and published. Like topics are used to organize all Kafka records, and consumer apps like read data from topics, whereas producer application write data to them. Record published to the cluster remains in cluster for the duration of configurable retentions period. Like Kafka keeps records in the log, and it's up to the consumer to keep track of where they are in log. The offset message or read consumer typically advances the offset in linear fashions. The consumer, on the other hand, is the charge of the position, as he or she can consume message in any order. Like when reprocessing the record, for example, consumer can reset to the older offset. And producer, a Kafka producer is a data source for one or more Kafka topic that optimize write publishing message partition allow Kafka producer to serialize and compress and load balance that among brokers. And consumer. Data is read by consumer by reading message from topics to which they have subscribed. Consumer will divide into group. Each group in consumer group will be responsible for reading a subset of partitions of each subject which they have subscribed. Another one is broker. A Kafka broker is a server that operates within a Kafka cluster, which is made up multiple brokers. Brokers work together to provide load balancing, redundancy, and failure capabilities. They handle high volume of read and write operation, processing hundreds of thousands of messages per second and gigabyte of data without compromising the performance. Kafka cluster is managed and coordinated by the broker using Apache Zookeeper. Zookeeper is used to tasks such as a leader elections, whereas a broker is selected to handle client requests for specific partitions of a topic. When a client connects to the any broker, it becomes aware to entire Kafka cluster state. To achieve reliable and failure, it is recommended to have minimum of 3 brokers. The more broker is cluster in the cluster, the higher reliable in case of failures. In summary, Kafka broker are key component in Kafka cluster responsible for handling data, ensuring redundancy, and coordinate with Zookeeper for the tasks like leader elections or failure. There are 4 core API architecture that Kafka uses. Producer API. The producer API Kafka allows to application publish a stream of record one or more Kafka topic. Consumer API. An application subscribe to one or more Kafka topic using the Kafka Consumer API. Stream API. Kafka Stream API allow to application to use stream processing architecture processor data in Kafka. Connect API. Kafka Connector API connect Kafka topic to the application. As we know that Kafka cluster we connect with connector, stream processor, producers, consumers, so that there are following basic concept in Kafka. First is role of the offset. In partition, messages are assigned a unique ID, as we seen that in picture. That unique ID number called offset. The role is identify each message in the partition uniquely. Second one is the partition key. Partition key indicate the destination partition of the message within the producer. A hashing based partition determine the partition ID when the key is given. And third one is partition of topic in Kafka cluster. Partition in a single piece of Kafka topic. More partition allow excellent parallelism when reading from the topic. The number of partition is configured based on on as per topic. So as we seen that in a picture, following leaders in Kafka. So leaders and followers are there. So partition are created in Kafka based on consumer group and offset. One server in the partition server as a leader and one more server act as a follower. The reader assign itself task, as we seen that in the picture. Reader assign itself task, read and write partition request, and follower follow the leader and replicate what is being told. Okay. So third one is the consumer group. When more than one consumer consume bunch of subscribed topic jointly in form of consumer group, as we seen that in that picture. So next. So what do you mean by Zookeeper in Kafka and what are its uses? Look, Apache Zookeeper is a creational component distributed application serving both as naming registry and distributive configuration synchronization service. Its primary role to maintain and coordinate consistency of distributed systems such as Kafka cluster. So here is a breakdown of Zookeeper's key functionality, its uses in Kafka. First one is naming registry. Like that, Zookeeper acts as a naming registry, providing centralized location where distributed application can register and discover service. In other the context, Kafka it's allow brokers and other component register themselves and make their presence known to the entire clusters. Second was distributed configuration and synchronizations. Zookeeper offer a distributed open source configuration service, enabling distributed application like Kafka to maintain a shared configurations across all nodes. Any configuration change made through Zookeeper are like propagate to all relevant nodes. Ensure the consistency. Third one is like Kafka cluster and coordinations. Like Kafka broker heavily like rely on Zookeeper to coordinate entire Kafka cluster. Coordinate with like with cluster topology changes such as when broker or topics are added or removed, undergo any modifications. So broker and topic management. Zookeeper keep track of status of Kafka broker, topic, partition, other important metadata. Fifth one is notification mechanism. When any significant change occur in the Kafka cluster, Zookeeper notify all the relevant node about the updates. For instance, if name broker join the cluster, Zookeeper broadcasts this information, allowing all other broker to become aware to the new additions. So, sixth one is a leader elections. Leader are responsible for handling read and write operation for specific partitions. Zookeeper enable broker to elect leader for partitions, ensuring efficient data processing and fault tolerance. Seventh is like safeguarding against like broker failure. In case of broker failure, unexpected delay because unavailability, Zookeeper play a crucial role detecting this failure and notify the rest of the cluster. This allow other broker to take appropriate action, ensure continuous operation and data availability. So what is the role in Zookeeper in Kafka? So first is like a hardware Zookeeper server. So like what is hardware Zookeeper server? So Zookeeper is not a memory intensive application when dealing with simply Kafka stored data. Typically like production use case like minimum 8 GB of RAM should be available from Zookeeper. And Zookeeper is also like Kafka metadata stored that does not require a loads of CPU resources. Has at that there is a, like it should be give a dedicated CPU core and like disk performance critical maintaining healthy Zookeeper cluster, and we advocate utilizations of like best performance because Zookeeper require like low latency disk like writes, and Zookeeper is often used as JVM but should have 1 GB heap size monitor heap utilization to avoid the garbage collection delay. And second, Zookeeper like provided stable connections. Zookeeper production deployment configure options are there, like configuration like they're following like essential setup parameter in Zookeeper, like server configuration setting may be modify functionality depends on like dependability and behavior. So first one is like the data directory, specify the location directory in which transaction logs like snapshot keep by Zookeeper. Client port, determine the port number like which Zookeeper looks like a client connection. Client port, the port is used by client connect to the Zookeeper. Client port is like a 2181. Like other one is like a Zookeeper tick setting, control how long tick lasts, which affect time related parameters such as synchronization and like session timeout. And third one is like Zookeeper setting determine the number of tick required for initial synchronizations affecting how long take for a Zookeeper server to join or recover from a failure. So like initial time limit is like 10 and synchronous like time limit it's like initial limit 10 and synchronous limit is 5. So Zookeeper server load control by setting the maximum number of concurrent client connection as per IP address, preventing accessing connections. So like max client it's like 100. So there is like advantage of Zookeeper like it make distributed system that coordinates with synchronizations, provide reliability, simplicity, speed, scalability, and like that. And that batching action together reduce round trip between client and Zookeeper server. So increasing throughput, reducing the network overhead. So like that role of Zookeeper in Kafka. So what are the basic concept in Kafka? So how do you start Kafka server? The following command must be done in order to start the Kafka server and ensure that all services are started in the correct order. Start the Zookeeper service by doing the following like commands like $bin slash zookeeper server start dot sh config zookeeper dot property file to start Kafka broker server. Open a new terminal and type following commands like $bin like slash Kafka server start dot sh config slash server dot property. So what are the use case of Kafka monitoring? Track system resources consumption. It can be used to keep track system resources such as memory, CPU, disk utilization over a time, and monitor thread and like JVM uses. Kafka relies on Java garbage collector to free up memory, ensuring that it runs frequently, thereby guarantee that the Kafka cluster is more active. Keep an eye on the broker, controlling replication statics so that status of partition replication can modify as needed. What is the purpose of partition in Kafka? The purpose to allow a single topic to be partitioned across the numerous servers from the perspective of Kafka broker. This allows you to store more data in single topic that a single server like can. If you have three broker, you need to store 10 TB of data in the topic. One option is to construct a topic with only one partition store all 10 TB on one broker. Another alternative is build a three partition topic, distribute 10 TB of the data among the all broker. So a partition is a unit of parallelism for the consumer perspective. So like what is the real life uses of Apache Kafka server? As a message brokers, like due to high throughput value, Kafka capable to managing huge amount of data, comparable type of message or data. Kafka can be used publish subscribe message system that allow data to be read and published in convenient manner. To monitor operational data, Kafka can use keep track metrics related to certain technologies such as security logs. Website activity tracking. Kafka can use check the data transferred received successfully by website. Kafka can handle massive amount of data creating by website for each page and for activity of user. Data logging. Kafka data replication between nodes and functionality can be used to restore the data on nodes that have failed. So Kafka may have also used to collect the data from variety of logs and make it available from the consumer. Stream processing with Kafka. Kafka may use to handle streaming data, which data that read from one topic processed and then written to the another. User and application will have access to a new topic containing the processed data. As we like saying that in this picture, like messaging, website activity tracking, metrics, log aggregations, like event sourcing, committed log. So that you so there are some disadvantage of Kafka. So first, Kafka performance degrade if there is a message tweaking, and when message does not need to be updated, Kafka works well. Wildcard topic selection is not supported by Kafka. It is necessary to match the exact topic name. Broker and consumer reduce Kafka performance when dealing with huge message by compressing and decompressing the message. This has can impact Kafka throughput and performance. Certain message patterns, like including point-to-point queues and request reply, are not supported by Kafka. Kafka does not have complete set of monitoring. Thanks everyone for watching and listening, and bye bye. See you soon.